Hello.
Hi, Kiran. Good morning.
Hi there. Very good morning. Just give a couple of minutes. Others are joining.
Yeah, sure.
Yeah, I think let's get started there.
Okay. Sure. So let me share my screen.
Yep.
So last time we were discussing about, so we had discussed about arrays and slices. Now let's understand what is a map. Okay. So map is also a kind of, you can say, data types in the Golang, and uh, it is a kind of like you can create a collection of unordered pair of key and value. Okay, so how you can create that? Let's check it out with the example. Syntax is very simple. So basically, we have to give a key type and then we have to give a value type. Okay, so
Mhm.
here like things will come always in a key and value. Okay, key and value meaning, let's say one key is their employee name, and after that there will be a value of your employee. Okay, so here we have the maps. Okay, so here in this example, if you see, so basically this is how we can create a map. Okay, so with the syntax, if you see, I am creating one variable that is am, and we are using a make keyword here to create a map, and then map keyword and string and then int. So string is for your key and then int for your value. Okay, so then after that, uh, so as you see, like line number 9 and 10, I'm assigning value and keys. Okay, so my keys are k1 and k, my keys in k1 and k2, and values are 7 and 30. And when I'm defining on this line number 7, so you can see string and int. Okay, so values are is int, and the keys are string. Okay, so
Mhm.
this is how we can create the uh, map. Okay, so now let's check it out. Let's run this example. So here I have the terminal. So in the terminal, let's say go run maps. Okay. So first output you can see on line number 12, that is whatever map you are going to give, that map will be printed out. And after that, you can print the single values of your map. So you can assign to the value, you can assign to different map also. Okay, so let's say you are creating another variable and you want to assign that a single value, key and value of a particular map, so that you can do. Then if you want to check out the length of a particular map, so you can just pass with the keyword len, so you will get the length. Then if you want to delete a value, okay, so you can delete with this delete keyword. And then after that, if you just print it out, so you will get nothing. Okay, so after that we have let's say if you want to parse it out, so for PRS you can just check it out this. And then lastly, if you want to create a map, and after that only if you want to assign the values. Okay, so this is how you can do that. So you can assign, you can define and then assign at the same time.
What is that underscore used before PRS?
Yeah, so when you don't care about the second variable, then we use
Okay.
underscore.
Okay. Key value pair.
Yeah.
Okay.
Okay. After that we have second. So next point is like pointers. So pointers are similar to the C language. Okay. So basically pointers are variable which store the address of another variable. Okay. So let's say I have two variables, variable A and B, and if a variable A is a pointer variable, so pointer variable will store the address of variable B. Okay, so if a particular variable is having the address of another variable, then it will have the complete access of that variable. Okay, then if we have the access to that particular variable, we can modify, we can manipulate the values also of that particular variable, like the variable B. Okay, how to do that? So let's check it out with the example. So here we have the example of pointers. Okay, this is good. So basically what is happening here is on line number 6, I'm having one simple variable, that is variable x. Okay. Type is integer, value is 30. Okay, and then on line number 7, I'm creating another variable. That variable is a pointer variable. Okay, pointer variable will we are going to define with the star. Okay, and then on line number 8, we are just getting the address of x. Okay, with the ampersand. So whenever we use ampersand, meaning that we are going to get the address of a particular variable which we are trying to access. So here the variable is x, and with the ampersand I'm going to get the address of x. Okay, same I'm printing out here on the line number 11, and then you can check it out. Since we are assigning it to it, so the IP also will have the same address. Okay, and then if you want to, if I'm having address of something, then I can get the values also. So on the line number 16, you will get the values also of x. So let's print it out. You will get the output. Go run pointers1.go. Okay, so you can see here. So first is address of x variable, that is this one. Okay, then address store on IP. So since I am assigning this, IP is equal to ampersand x. So for that also I will get the same. And since I am giving access to a particular address, then whatever value you store on the address, the value also can be accessed by the pointer variable, that is IP.
Okay, so this percent exclamation extra is a address notation.
Yes.
Okay.
Another way, example I have is this one. So this also does the same thing. Okay, so basically this is a function, this is second function. So here I one simple variable, okay, and one pointer variable, and basically we are just trying to access the simple variable from the pointer variable. Okay. And also now if you want to modify the value of this x, okay, so you can do that. Why you can do that? Because you have the access to the memory. Okay, so if you have the access to the memory, then you can do what you can do whatever you want to do with that particular variable. Okay, so this is all about the pointers in Go. Next is interfaces. Okay, so interface is a custom type. Okay, this is the last type in the data types. And in the interfaces we specify, we used to have the set of methods. Okay, so when you want to create a kind of we want to use the set of methods in the Golang, then you can use interfaces. It is just like I think in OOPS programming also, when you want to I think like collection of classes you can use, so very similar to that. Okay, and here if you see one example I just give you here, so interfaces will look something like this. Yeah, so I have two methods here. One method name is here area and volume. Okay, so one method is t area. Okay, second method is volume. Okay, now this two methods I just want to use in a single at single place. Okay, so basically what how I can do that, so we can create an interface like this. This is the interface. Okay, so in the interface how we can do that, this is very simple. Like you have to just use a keyword interface and then similar to structure. Okay, and then here I will call two methods, t area and volume. Okay, and then this tank interface I can use at multiple places. Okay, so here you can see t dot t area, t dot volume. So this is how we can use the interfaces. Okay, so moving that, after we have the JSONs in Go. Okay, so JSON you might have understand. So in the JSON what we have is we have the this is a custom data type actually, and we are going to work heavily with the JSON. Okay, so basically in the JSON we store the data in the form of key and value. Okay, but it is not like we have to create a single data type only. We can use multiple data types with the JSON object. Okay, so a very simple example, if you see here, let me open this. Okay, so here also in the chain code, if you see, basically here we are just defining the JSON, right? So basically when I create or when I send the request to the chain code, my request will come in the JSON format. Okay, so in the JSON format meaning in the form of p and value. Okay, so values will come from the calling function, from wherever I will call that particular function. Okay, and those values will come here and then it will assign to the keys. Okay, so instead of make, you will get the make, whatever make you pass from the calling function. Similarly, model, honor, and color. Okay, now one very simple example I just give you here. So I have a postman here. Okay, so in the postman I will show you how like the JSON format will look like. Okay, so basically it is just the object. Okay, so if you are working with the JavaScript, so you might be knowing about the objects. So it is a very simple object, just like our JavaScript object. So and also one thing to remember is we pass the data generally to the Hyperledger Fabric chain code in the form of JSON. Also, we receive the data in the form of JSON. Okay.
Through the REST APIs, right?
Through the REST APIs. So we are going to use JSON heavily. So this is how, if you see, so this is a JSON format. Okay.
Right.
So we pass we send the data in the form of JSON and we receive the data in the form of JSON. And after that, okay, after that we have another concept, that is error handling. So error handling is you can check it out here. Okay, so whenever if I receive any error, okay, so just look at this 679 of code. Okay, so basically whenever you write a chain code, you have to do the error handling. Okay, at every places wherever you feel, okay, this is where like a major operation is going on, like while storing the data, while reading the data, while converting the data into another format. So these are the places where we have to use the error handling. Okay, so how you can do the error handling? So basically you have to create a variable, and then you have to just check it out with that variable is coming empty or not. Okay, so just like if you can see here on line number 143, just highlighted here, I highlighted here. So I'm creating a variable that is ERR. Okay, and I'm just checking if that variable is not empty or not nil. Okay, if that variable is not nil, then I will give a error. Okay, so to give error we have to use a library that is error. Okay, so you can see here err dot error, error, that is the keyword. So wherever you do the error handling, you have to use this keyword. Okay, there are other keywords also which you can use, but mostly we use this error keyword.
Okay, so is this similar like try catch we use? So we don't have.
Very similar. Yes.
So we don't have try catch in Go.
Yes, we don't have. So we just do the error handling with this pattern only. Okay. So at every places, because it is the language will go line by line. Okay. So line by line your code will be executed. It's not like one line is executed, then it jumps to line number 10. Okay. So that will not happen like JavaScript. So it will just go line by line. Whatever comes in between, it will execute that. Else it will stuck over there only. Okay. So this is how we do the error handling in the Golang. Okay, as well as in the chain code writing. Now, just look at this Fabcar example and check it out whether you are able to understand something or not. Okay, so first thing is package name. So by this time you must be understanding why we are giving a package name here. Okay, because every Golang program will have to have a package name. Okay, after that I am importing the libraries or the packages from the go.org, right, or go.dev. Those packages are encoding JSON, FMT, str conversion, and contract API. Okay, so first is encoding JSON. So why we are using encoding JSON? Because we are working with the JSON, right? How we are working with JSON? So just come here. Okay, so you can see JSON.marshal. Can you see line number 50?
Yes.
So since I am using JSON.marshal, okay, that is why I'm importing JSON encoding / JSON. Okay, and now why we are using the marshal? So marshal is to converting your data which is in the form of JSON to byte format. Okay.
Okay, so these packages are already there when we install Go. We just need to import them as and when needed.
Yes. So contract APIs will not be there. Contract API, when you create the new chain code. Okay. So first time you have to import that. Okay, or you have to download that. So I will tell you how to do that. But first time you have to do that. Okay. Second time it is not needed.
Okay. We can just import them when needed.
Yes, you have to just import them, and that's it. So here marshalling. Okay, so marshalling is when you want to convert your JSON data to the bytecode. Okay, because ultimately in the blockchain your data will be stored in a byte format, so you have to convert into the byte format, and then that can be done by marshalling. And another thing is unmarshal. So unmarshal is when you read the data you will get in the byte format, so from byte format you have to just convert into the JSON format. Okay, so for that we use JSON dot unmarshal. So remember these two things.
Okay.
Okay, and this is only for your Golang program. Okay, when you write in JavaScript there is another process where we use buffer. Okay, so for Golang only we use marshalling and unmarshalling.
Unmasked.
After that, uh, another we have imported, that is FMT. So FMT by this time you must be knowing. FMT is another one where we use printf, print line, so log. So these are coming from this FMT uh, package. Okay, then we have the str conversion. Okay, so str conversion basically if you want to convert something, into the uh, string to the numbers. Okay, so basically here we are just using that. So car plus str conversion dot iota I. Okay, so what is happening here is I just need to get a number. Okay, so for that I'm using this. So this uh, I to I will give me a number. Okay, based on the loop, whatever loop is, whatever the current loop number is. Okay, so that is why I'm using this str conversion. Str conversion is also being used to convert your string to numbers. Okay, so there are multiple use case where you can use your str conversion in the chain code writing. Okay, after that we have another one is your contract API. So contract API is basically we are using to create the contract. Okay, also write the chain code functions. So first we are using here, so here I am creating a structure for my contract. Okay, so creating a structure for contract, we are using contract API dot contract. So contract is a function or class inside the contract API. Okay, so using that we are going to create a structure for our smart contract. Okay, so every time whenever you write a smart contract or a contract for your chain code, you have to create a structure for your contract. Okay, and that structure can be created by the contract API. Okay, after that these are my assets. So assets can be created with the help of structure. Okay, so structure, as I said, is a collection of key and value. Okay, so you can create the structure here. So one structure is car, second structure is query result. Likewise you can create multiple structure as per your requirement. Okay. After that, this is the init ledger function. This is very first ledger function or first contract function which needs to be executed to work with your smart contracts or your chain code.
Yeah.
Okay, this is the very first function to start your ledger or start your chain code. Okay, another important thing which you have to just keep it in your mind is put state and get state. So this is the put state. Okay, on line number 51. So why we are using put state here? Because we have to write the data to the ledger. Okay, so we are writing something to the ledger, right? So whenever you are going to write something to the ledger, you will use put state. Whenever you are going to read the data from the ledger, you will use get state. Okay, so this is important. Get state and put state. Clear?
Yeah.
Okay. So now other things are very similar. Now let me explain, or let me give you an overview of JavaScript chain code also. Okay, because personally I prefer writing chain code in JavaScript. Okay, because of some obvious reasons of playing with the objects. Okay, so in the Golang, playing with the objects is very difficult. So that is why I just prefer, well, like whenever whenever there is no issue with the performance. Okay, if a very simple use case is there, JavaScript is the best option for now to write the chain code. Okay, so I think you guys are aware of, like, you know the JavaScript, so it will be easy for you to understand this. Okay, so basically on first I'm having an index file here. Okay, just like our main file, main.go, we have an index here. So in the index, what we are going to do is we are just importing the our contract. Okay, so my contract name is Fabcar. I'm just importing from lib/Fabcar. Okay, and from here I'm just exporting this Fabcar. Okay, this is my chain code name. Fabcar is my chain code name. Okay, so logic is written here. So here you can just check it out. First, I'm going to import the contract API. As you know, we need the contract API. So first is we just have to import the contract API that we are importing with the contract. Okay, and then one class we are just going to create. Okay, for the Fabcar. Okay, that is contract. Okay, so inside this contract, I am going to write all my functions. Okay, so inside this, first function is init ledger. Okay, this is a async function, and that is init ledger. And CTX is the same for contract API. Okay, so then inside that, here we are just going to create a variable cars. Okay, and cars will have n number of, or total 10 number of objects. Okay, so basically multiple objects I'm going to create inside this. Okay, so these are my objects. After that, same logic, one for loop here. Okay, and in the for loop we are just converting the data into the bytecode with the help of buffer.from. Can you see here?
Okay.
Okay, so buffer.from from. Okay, and then I just convert, or I just stringify the object here. Okay, with the help of JSON.stringify, and then I will pass one by one all the cars object. Okay, and that's it. Clear? So you can just check it out the difference. Okay, logic is pretty much same, and here also we are doing the exact same thing only. Okay, but here we are doing just a marshalling, here we are doing the buffer. Right? Second thing is, if you want to query a car. Okay, so basically for query a car, you have to just write this function. Okay, so car as bytes, await. Obviously, if we are using async and await, so say function will be whatever inside function you are going to write, or inside call you are going to do. So that function you will use with the await, because you have to wait until you get the data from the ledger. Okay, so that is why we are using await here. And then ctx.stub and then get state. And if I pass the car number in the get state, I will get the data. Okay, so put state and get state, same. So once we receive the, so here we are just doing the error handling. Okay, so if we don't get anything, then we'll return a car does not exist. If we get it, okay, so we'll return the complete car as byte and to string. Okay, so basically we'll just convert into a string, and then we'll give it back. After that, let's say if you want to create a new car, okay, so simply you have to create a variable, sorry, you have to create an object here. Once you create an object, just put that object into the ledger. Okay, so let me tell you why I prefer to write the code in the JavaScript. Okay, I just show you one code here. Okay, so we have one of the use case we were working on. Okay, so in that use case, what we did is, since the use case was something like, okay, we have to just store the data into the blockchain. That's it. Okay, we don't need to care about, okay, inside the chain code if specific logic is there. Okay, there was no specific logic, only you have to store the data. That's it. Okay, just like other databases. Okay, so what we did is we just created a common function. One function is to write the data. So if any type of data comes, okay, so basically an object will come. So let me open that and then I will show you. Because generally in the blockchain we might receive this kind of use case where client only want to store the data into the blockchain. Okay? They don't want to do any specific things on the basis of user IDs or user roles. Okay, those things they just want to kind of handle at the middleware level. Okay, so in that case, so okay. Okay, so you can see here, I just have written this 6 line of code. Okay, and this function will work in all the, whenever you are going to write any new data. Okay, it can be anything. Okay, this single function will work. So basically, in this kind of scenario where you need this, like you have to just store the data, and other logic you can handle on the middleware level. Okay, so on those kind of scenarios, this kind of thing can be done on the chain code. Only one function for creating data, only one function to updating the data here. Yes. Like this, as well as only one function to get the data. So for get data also I have the function. So to get all. Yeah, this is the one. If you want to get the complete records, okay, so simply one function we have written, and in that function what we did is we created a query string. Okay, so query string I will explain you how to use query string. This is just like in the NoSQL database, if you want to get the filter data, okay, then you can use the query string. Okay, so query string is something like in SQL database you might be doing that, like select from this table to from this table, like basically getting data from multiple tables, right? That can be done here also. So in this let's say you want to get the data only from a particular table. Okay, so here we segregate the data in the form of collections or tables, like tables in SQL and collections in MongoDB. Okay, here we define with the help of doc type. So when I create create a record, I will mention this what is the type of this particular document that we mention in a doc type. So doc type is basically, let's say user is there, employee is there, then if payment record is there, so payment is a doc type, like this. Okay, so generally we define our data, or we segregate the data with the help of doc type. You can define in other options also. Okay, so other field also you can define, and you can segregate your data basically.
Yeah, a kind of filter parameters.
Huh.
But what about that update function? Will it update the existing blocks on the ledger or what?
No, so see, whenever we use update, okay, so in update what happens is your world state would be updated, okay, but in your blockchain a new block will be created.
Okay.
Okay, so your data old block is never going to update. Okay,
Right.
that is final, that is history.
Mm-hmm.
Okay, on top of that a new block will be created, and your updated data will be stored in that. And whenever you search for a history,
Mm-hmm.
so for a particular index you will get the complete history. So you will get the complete, like if you did update on a particular record for 100 times, and those are stored on 100 blocks, different blocks, so your all 100 data will come from all 100 blocks, and you will get the complete history.
So there will be any kind of mapper that will
index would be there.
Index will be there. Okay.
So just like we write the methods in .NET, so is this the same to get the data?
These are functions basically. Okay, so in JavaScript mostly we work with the functions and the object. Okay, so these are the common functions. Yeah, of course you can relate with the common classes in the C#. Okay.
Yeah.
Like one class you write, and then that class you can call multiple times from multiple places. So this is also same. Okay, but here we call it as functions. So classes we don't have in the JavaScript, so we have the functions here. Okay, and how you call these functions? So let me open that one also, so you will get a good understanding how you call the functions. Okay, so let's say I have this order. Okay, order is one of my function. Okay, so basically like this. Okay, so we have this we have this routes. Okay, so let's say if you want to get the get order by ID, then if you want to get complete orders, if you want to create an order, so that is post order, update order, delete order, or if you want to get the order by a particular user. Okay, so let's say if you want to get the get order by ID, so simply what I'm going to do here is this is a line of code which I execute, and then I will get the order. So basically I have to just pass the index, that is the unique ID. Okay, and the function name is get by ID. Okay, this is my middleware. Okay, from here I'm calling the chain code, and so get by ID is my function name. Okay, so if you search in the chain code here, you will find one function that is get by ID. This is the one. Okay, and this get by ID is expecting two things basically. One is ID, second one is doc type. Okay, so ID you can see here. This is the ID I'm passing from here, and the doc type. So doc type is order. So I just want to search. So I can have ID. So ID is like a common common field which I'm having in all the documents. So all documents will have an ID, right? So but I just need to search only in orders. Okay. So let me show you another things.
So ID can be considered as hash of that block or not?
Not hash, no, not hash. So see, right now we see, you have to remember one thing. We are getting data from world state. Okay, I'm generally whenever I want to get the latest state. Okay, so I get the data from world state, and world state database is non-blockchain database. Okay, this is the world state, that is a CouchDB right now I'm using. Okay, this is a CouchDB database for the same application.
Okay.
Okay, so here the data is in the JSON format. You can see this data is JSON format like this.
Okay.
Okay. So here, let's say if you want to get a particular data, let's say this data you want to search it out. Okay, so what you have to do is you have to just provide an ID. Okay, ID and then doc type. So basically my system will search it out in this doc type. First it will select the doc type. Okay, so let's say doc type is calculation or metal. Okay, once doc type is finalized, then it will search the ID and then it will give the particular record which I want here. So whatever ID I give and then order. So it is not going to search in all IDs. So it will just filter out first with the order and then in order it will search with the ID. Okay.
Okay, so it will basically do search in this CouchDB.
Yes, CouchDB. Yes. So it is
blockchain.
So here I need a latest information, right, for a particular order. Okay, I don't need the history. So when you need the history, then you have to call a different function. Okay, so get history by ID, that is different function. Okay, so when you need a history, then your call will go to blockchain database. So Ledger has two parts. You must be knowing that world state and the main blockchain. Okay, so generally 90% of the 90% of time you will get the data from world state only. Okay, and it is not like world state is not secure. That is very secure compared to your other databases. Why? Because it is decentralized data. Okay, if you change something in your database, let's say you can say this is your database, and of course you can modify some anything from here because you are able to access the database, right? But the point you modify the database, your database is gone. Your record is gone. That particular record is gone. Why? Because you have modified here. Okay, but that is not modified on other instance of database, which other peers are having. Okay, so all your peers will be having the same copy. Okay, and if your is different from others, and others are like they are having the majority, then your database is explicit. So whenever you do the next transition for a particular record, your transition will be failed. Okay, so the point here is why they have introduced this particular CouchDB, okay, or a label DB, or basically world state. Why we need a world state here? So you can see, like, if you search in the block, okay, if you search in a block, of course you will need extra time. Why extra time? First is you are searching in a blockchain based database. Okay, blockchain based database data is available in the form of hash. Second thing is in the form of blocks. Okay, searching in a block and searching in the normal database is quite different. Okay, second thing is here you are having only one record. Say, let's say for a particular this metal group. Okay, so for this particular metal group, you are searching with the ID. Okay. Also, you have the version, right?
Mhm.
So what happens is, here you, since you are having with one index, you are having only one record. Okay. With this ID, you will find only one record. That is for sure. This is my index ID, and with this index ID, I will get only one record in the cows DB or in the level DB. You understand, right?
Yeah.
Why we are getting
Yeah.
only one record? Because it is a non-blockchain database. In the non-blockchain database, we don't create new record. We just update the existing one, right?
Mhm.
But in the blockchain database, that is not the case. So for the same ID, for same index ID, you will get the multiple records. Why multiple records? Because in the blockchain, we don't update anything. We just create a new record with the updated values. Okay. So with the same
Yeah.
ID, you will get the record in block number 10 also, and you will get the same thing or updated record with the same ID on block number 100 also. Okay. So the number of update you do, those number of instance or the number of records with the same ID you will get in the blockchain. Okay. So your system has to filter out in that, okay, which one is the latest one with the help of time. Okay. So the searching will take time, you know that, right? If you run some SQL jobs which will search your data and create a report, so searching can be a day-long process, right?
Mhm.
To reduce this time, and this is the main problem in all the blockchains. Okay, you can take any blockchain in the industry, Ethereum or other blockchains also, right? All comes to a point where they will face the performance issues. Okay, where people will say it is not scalable. Okay, here Fabric is trying to solve that problem. How? With the help of
This world
this kind
state.
of, yeah, with the help of world state. Okay, so instead of searching in the blocks, okay, what we do is we store the latest value. Latest meaning the latest update which happened on a particular record, we store in the world state, only latest.
Mhm.
Okay. So when next time I am going to do any kind of uh, update on a same record, I will not go to search in the blockchain, okay, or in the inside the blocks. I will search in the world state. Here I will get the latest value of a particular record,
Mhm.
right? So this is the importance of your world state here. Okay, and with the help of the world state, you can do the rich queries also. Okay, rich queries meaning, see, every application needs a query functionality, right? Let's say in blockchain, queries is a kind of is very complex process. You cannot do the queries like large queries or rich queries in the blockchain database. Why? Because data is stored in the blocks, and then single data you can search it out very easily. But if you have the multiple conditions, like you have to get the data from like multiple places or with the multiple IDs, then it is very difficult. Okay, but here you can write a query also. Why? Because it is a cows DB, and that is a non-blockchain database. Okay, so you can see one function we have written here. So that function, what it does is, let's say get order by user. Okay, just look at this. Here what I'm trying to do is I'm using one function that is find. Okay, this function is available inside my chain code. Okay, this is a universal function. Okay, so with the universal function, what we are trying to do is, I just need to pass a doc type here. Okay, in the doc type, it will not search with the ID. What it will search with? It will search with user.
Mhm.
Okay, so basically on the user field, so like this, you can have any field, not only ID, but you can search with any field. Are you getting my point?
Yes.
Yeah.
So any field. So right now I'm searching with user. So let me open uh, one order. Okay, so it will be easy for you to relate. So I'm searching with any field here. So this is my order. Okay. So in the order I have one user also. This is the one,
Mhm.
right? So I'm searching with user here, but I can search with let's say cart number. If I have the card, if I have the address, I can search with that. If I have the let's say transaction number, so I can search with transaction also. So any field I can give and I can search that record from the world state. It is not possible with blockchain database. Okay, you can't do that.
Yeah.
Okay, and of course people will say, okay, this is not the complete blockchain or here and there, but without that if you don't tweak the things, you cannot create the you cannot compete with the like the applications which are running right now.
Yeah.
Okay, because these people are like they are like, okay, we have to have the reporting functionality, we have to have the kind of searching power, right? And of course blockchain will provide the security, and with this setup also you are getting the security. Okay, it is not like there is a security flaws. Okay,
Mhm.
that is not going to have by because it is a decentralized data. Like your data is not centralized. If someone is like trying to get your database, still they can't do anything. Okay, they can't change any database because it is a decentralized one. Okay, so security wise there is no problem, but with the same we have to get the performance also with multiple functionalities of searching and sorting, also the filter, and that will come with the help of only with the world state in the Hyperledger Fabric.
Okay.
Okay,
Yeah.
fine. So uh, next uh, next what I am going to do is, so is the network is
Basically, just one question. The example that you shown. So whatever practice or assignment that maybe you can give us, can we try to create one simple project with the same structure where we can create a common library where, like you just shown you for goal
yeah.
goal ordering chain code. So all the common functions like get on or get by ID or put or update these states. So we can have that skeleton created basically that we can refer further for multiple projects
Yes,
going.
yes, you can do that. So so let me complete this CouchDB part. Okay,
Yes.
and basically 2 assignments if you guys can do, that's well and good. If not, I will explain you. So basically one is on the network part. Okay, so how you will modify the network and then create your custom network, and second one is how you write the chain code.
Chain code. Okay.
Okay, so you can decide like which one you want to take first. Okay, I was about to give that, and
Okay.
because see training part most of the things are completed, only SDK is remaining. Okay, so once you guys are fine with this like creating a custom network and writing some basic chain codes. Okay,
Yeah.
then we can move to the Node.js part, or sorry, SDK part,
Yes.
where like you will be writing a custom middleware, and then you are connecting to your application, your chain code. Okay, so
Yeah. Yeah, so I think setting up the networks and tweaking the networks should be the first one, because we all need to understand the chain code setup and updating the networks based on that. Not chain code setup, the network setup. Once we get comfortable with that, then maybe we can move on to chain code related stuff.
Yeah, sure. So do one thing now. Okay, take this as an assignment. So basically you guys have like I have explained you the test network, right?
Yeah.
So in the test network you can see like you have here, this is the test network, right? So
Yes.
now
Yes.
let's do very simple thing. Okay, so we have that project also ready with me. So that is insurance application. Okay, so In that project, what exactly we have to do is we are just creating a very simple network with the two organizations. Okay, so two organizations, organization name, give it anything. Okay, in my case, I have given like SBI Life and SDFC Life.
Okay.
Okay, so two organizations should be there. Then two peers in each organizations. Okay, so peer 0 SBI Life, peer 1 SBI Life, and peer 0 HDFC Life, and peer 1 HDFC Life.
Yeah.
Okay, so and one channel. So that channel name you can give insurance channel. Okay, so with this basic configuration, if you guys can create a network, okay, using like you can get the reference from test network how the configuration has been written. Okay, so if you can try it out, that would be very helpful for you guys.
Yes.
Okay, so just give a try, and if you face any issues, any confusion, so we'll discuss that.
Yes. Sure.
Okay, so order, keep it only one for now, and don't change anything on the order side. Just do the changes on the organization side. Okay, so two organizations, four peers, and one channel.
Yes. Okay.
Okay, so take it this assignment, and then maybe daily we can discuss. Okay, what is your progress, how you're when you are stuck, and if you want, meanwhile we can continue the training also, like further
Yes,
parts.
yes, definitely.
Okay.
Yeah.
Fine then. Yeah, you can start. And tomorrow I will explain you the CouchDB part. Okay, how you can integrate the CouchDB with the Fabric. Okay, and then we'll have the Hyperledger Explorer integrated with our network. Okay, and after that we'll go to maybe this Fabric CA. Okay, that is certificate. Okay, so we'll try to complete these three things in this week, and then we'll move to the SDK part.
Okay.
Next week maybe.
Yeah.
Okay.
Yes.
Yeah. Okay. Fine then.
Okay then. Thanks. Thanks for your time.
Yep.
Have a good day.
Thanks
Bye.
everyone.
Bye.
Thank you. Bye.